Okay, continuing on in section 1.7. So this is still section 1.7. And we're going to be talking about order of operations now. And everyone's familiar with the mnemonic PEMDAS, right? So this order of operations. And you guys remember PEMDAS, or please excuse my dear Aunt Sally. Right? So again, we talk about for each one of these letters, it means something. Parentheses, exponents, multiplication or division, whichever comes first. Doesn't have to be multiplication, could be division, and then addition or subtraction, whichever comes first from left to right. So again, the P is for parentheses or any grouping symbol. We have parentheses, we could have these square brackets, we could have our curly brackets, any grouping symbol, which includes the fraction bar. It's just a fraction, the bar between the numerator and the denominator. Your absolute values, and your radical, your square root symbols. These are all grouping symbols. The next thing you look for are exponents. And then we have multiplication or division, whichever comes first, left to right. Left to right. And then the last thing we look for is addition or subtraction, again, whichever comes first, left to right. Okay, so this is what we call the order of operations agreement. So given no grouping symbols, we agree that anytime we see parentheses, we work whatever in the parentheses or any other grouping symbol first, followed by exponents, and then multiplication or division, and then finally addition or subtraction. Okay, so let's try a couple. I'm asked to evaluate 15 minus 10 divided by 2 plus 3. Okay, so going from left to right, the first thing I look for to see is if there are any parentheses, which I don't see, exponents, which I don't see, and then I look for multiplication or division. Bam, I see it right here. Right, so I encourage you to change just one thing at a time. So I'm going to do 10 divided by 2, and that's going to be 5 plus 3. And rewrite everything over and over again. Right? So this minus sign came down here. I have a 10 divided by 2, which gives me a 5, and then I have a 3. Then now if I go from left to right, I see a subtraction and an addition. And remember, since the addition and subtraction are the same level, whichever one comes first, left to right, is what you need to do first. So I'm not going to do this 5 plus 3 over here. I have to take the subtraction. I have to have 15 minus 5, which gives me 10 plus 3, or 13. Okay, let's try another one. If I say evaluate 300 divided by 7 minus 2 quantity squared times 2 squared. Okay, so again, if I go from left to right, the first thing I spot is something inside parentheses. So I don't change anything else. I have 30 divided by, and I'm going to have 7 minus 2, which is going to be 5, squared times 2 squared. Okay. Keep going. Now the next thing I see is exponents, right? I have an exponent here and an exponent here. So I'll take 30 divided by 25, which is 5 squared, times 4. Okay, again, going from left to right, I see a division and a multiplication. Remember, multiplication and division are at the same level, so it's whichever one comes first. So I see 30 divided by 25 gives me 12 times 4, and my answer is going to be 48. Okay, let's do one more. If I say evaluate or simplify, and let's make it a little bit longer. So I have 300 minus 4 times the quantity, 4 plus the quantity 5 plus 2 all squared, plus 8 minus 31. Okay, so when we see something this long, again, remember our curly brackets, our square brackets, our parentheses, they're all just like parentheses. And you want to start training your eyes so that they go to the innermost set of parentheses. Right, so I'm going to start in my innermost parentheses here. And again, until you're used to doing a couple different things at once, I recommend that you only change one thing at a time. So if I look inside the parentheses, I have 5 plus 2, that gives me 7. I still have that squared out there, plus 8 minus, curly bracket, minus 31. Okay, now my innermost parentheses is this. So if I look at what's inside, I have to do the exponent, right? So I have 300 minus 4 times 4 plus 49 plus 8 minus 31. Still working inside my parentheses, the innermost parentheses, I have 300 minus 4 times 53 plus 8 minus 31. Now I don't have anything else inside these parentheses. There's no operation here, so that's just like the number 53. So I move out to these. And if I look inside this area here, I see that this is the multiplication I need to do. Right? So I have 300 minus 4 times 53 is 212. And then I have plus 8. That's all inside here. Minus 31, which gives me, if I work over here, I have 88. Okay, so I have 300 minus 212 gives me 88, plus 8 minus 31, so that's just 96 minus 31. And my final answer is 65. Okay. Okay, in the last part of this section, we're going to now talk about algebraic expressions. So, I'm going to talk about algebraic expressions. And I'm just going to make a comment now because we haven't talked about equations yet. But there's a fundamental difference between an expression and an equation. And an equation always has an equal sign in our problem. So the key to algebraic expressions is this is where we're going to start introducing letters, right? So we talk about our variables. And those are represented by letters. And you can remember this. What does variable mean? It means it can change, right? And that's why we put a letter in there, because That letter could be anything. So these quantities can change. And then we have constants. And these are represented by our numbers. And basically our quantities are constant. They don't change. So I might have an expression like this, n plus 30. Right, this is a variable, and this is a constant. I might have x minus y. Both of those are variables. Right? 3w. All of these are algebraic expressions. And again, this means 3 times w, right? If you see if you don't see an operation between a number and a letter, it's assumed to be multiplication. So it's 3 times w. Okay, so why are variables important? Well, remember we talked about, say the area of a rectangle. And we said area equals length times width. Well, we're using 3 different letters, right? They can all change. And depending on the length and the width of the rectangle, your area is going to change. So we just give a letter representation for a value that could change. Okay, so we're often asked to evaluate an expression if we're given values for our variables. So you might be asked to do something like this. Evaluate the expression 5a plus b when a equals 6 and b equals 10. Well, I like to put little parentheses around for any time I have my variable. So this is like my a and that's my b. So I have 6 in here and I have 10 here. Now it just becomes an expression that I can evaluate, just like we were doing in the previous section, right? So I follow my order of operations. I have 5 times 6 gives me 30, plus 10 gives me 40. Done. Okay, how about evaluate x minus y plus z squared for x equals 12, y equals 9, and z equals 14. Okay, so I want everything on the inside here is going to be squared, right? My x is 12, my y minus y, which is 9, plus z, which is 14. Okay, so I have 12 minus 9, which is 3, plus 14, right? The whole thing squared, which is 17 squared. And I don't know that one right off the top of my head. So I'm going to take 17 times 17, 7, 7, 49, 119, and then another 17. So I have 8. So the answer is 289. And I've just evaluated this expression for specific values of x, y, and z. If x, y, and z are a different number, my expression evaluates to something different as well.